So, let us start with the next one, food process regulations. When you are processing food, lot of things you do it in the plant environment is driven by the regulations. So, today we are going to talk about some of the regulations, probably from US perspective. So, these are all US based regulations. These probably may not be applicable if you are working in an Indian food processing plant. Nevertheless, I think many regulations originate or originally developed with a science based approach. So, that means these are all common sense, right. Like a lot of things you need to do is common sense, but somebody tried to provide them as a guidance. So, those are written eventually as a regulations. So, rather than blindly following them, trying to understand why it came through and then what is the purpose, so that you could be able to effectively utilize them. If you look at the US, we spend about $1 billion in food safety regulations. Like if you look at a lot of the food processing plants, you may have a specialist regulatory person who may be looking after whether or not we are compliant with the various things FDA or USDA or local authorities doing. So that there. But remember, the regulations are there ultimately to protect the consumers, because I think that is the purpose of regulations. They are there to protect the consumers and public safety. And these include from farm to fork. So, that means there are things you need to start doing. For example, you take milk from your farm and then you pasteurize it and then send to home through supermarket. Each step there are certain regulations you need to focus on. US regulations focus on science based decision making, and other thing from the US side, and which is probably true in India as well, you have a federal government, you have a state government, and then you have a local government. Each may have different control over your processing plant. The regulations kind of also span from farmers, food processor, distributors, importers, and others. And I think the context by which you need to also think about this is, you may be preparing a processing ingredient, or you may be preparing some solutions which may be exported to US, and if you do that, then that company may ask, is this prepared as per the existing FDA or USDA regulations. So, that means you have to make sure that is properly prepared and so on. So, having a knowledge of some of these regulations, not only in the US, Europe has its own set of regulations, and India has its own set of regulations. So, you have to do it, and ultimately when you are exporting a product to a country, then you need to make sure that you follow those regulations and meet those expectations. Otherwise, the country may say, okay, I am going to reject your product because it is not in compliance with our regulations and so on. So, you have to kind of pay attention to the details. So, what we are trying to do here is, this is primarily focused on public safety, particularly microbiological safety. So, that means you kind of want to look at pathogens in raw products, toxins, contaminants. So, there is a discussion yesterday that there are certain toxins, if you are allowed to proceed, they may not be killed or eliminated by some of the processing techniques. So, the best place is to avoid having toxins and similar contaminants in your food systems. You may have pesticide residues, so you kind of want to take care of them, metals, allergens, and you also have, with the recent days we are living in, there may be intentional contaminants and tampering. So, like bioterrorism, things like that. So, you have to kind of vigilant about all these different things. And if you look at the US, there are 12 agencies which govern food processing in food, and there are 35 regulations, and then you also have a state and federal government. What gives the FDA and USDA the authority to regulate is something called Pure Food and Drug Act, which is passed by the Congress in 1906. So, it's kind of started as early as 1906, the Pure Food and Drug Act, and that basically gives the FDA the authority to regulate various food processing plants. Now, let us look at some of the key regulatory agencies. So, again in the US, there are multiple agencies, and each agency has an oversight. So, you may have a processing plant where you may be only processing food products which are regulated by FDA, or you may have a processing plant which regulates products USDA, or it is possible you may be doing where FDA has authority over some portion of your plant, and the other portion is regulated by USDA. So, you have to kind of pay attention who is controlling what and make sure that you satisfy their needs. FDA is probably one of the major regulation, and they do most of the food except meat and poultry, and they do not do bottled water, wine, and so on. So, they do 80% of the food supply, they cover seafood, dairy, and produce, and so on and so forth. Now, with the interesting thing is with the new developments, like for example, we have different type of meats which are not necessarily meat, but it is produced in a lab grown meat. The question kind of come in, is it governed by FDA or is it governed by USDA, because these are new technologies and the regulations not caught up with them yet. So, there are some classes of products still undecided because of the new technological advances. USDA basically cover a lot of the meat products, meat, poultry, meat containing stews, pizzas, frozen foods, and so on. They get their authority, Food Safety Inspection Service get authority from the Federal Meat Safety Inspection, which is passed in 1906, and then poultry product inspection, slaughter, and then egg product inspection, and so on. So, the regulatory agencies FDA or USDA, they cannot just simply get into a processing plant and demand I can regulate these products. So, for each of them they have to be authorized by act of Congress, so that they have the authority to do some of those oversight. EPA, basically the Environmental Protection Agency, they kind of oversee the pesticide, drinking water, prevention of toxic substances waste into the processed food. The next one is the Center for Disease Control. They kind of look at the how foodborne diseases outbreaks spread at different locations and so on, and they kind of also do surveillance and so on. With the internet available, what we see is that they have a better opportunity to get all the outbreaks reported. In the past, some of those data were not reported properly, so they were underreporting the information, whereas in the age of internet, information can be readily reported, and then with the presence of Google and many other software, when the disease is spreading, they can able to do a better job in tracking which regions have certain disease or emerging based on the keyword search, internet search, all those things. So, they kind of have a better control over some of these things now. National Oceanic Atmosphere Administration, they do seafood fisheries, and they kind of collaborate with the FDA on related tasks. So, one of the things oftentimes discussed, if you look at FDA or USDA, they do a lot of things very similar or parallel, but they probably have two major agencies, and they follow different procedures. And if you are a processing plant, you are doing processing of both products in the same place, you may have to do 2 sets of regulations and so on. So, there has been talk about merging FDA and USDA as a single food safety agency, but that requires the act of Congress, and I think that probably did not happen before. So, they still have 2 separate agencies, but they kind of collaborate with each other in terms of some of the related things. So, for example, when you talk about novel processing technologies, oftentimes the FDA takes the lead in terms of review the technological advances and then ask the questions, and then they issue letter of no objections. When FDA is satisfied, then USDA may follow through for its own version of the regulations for meat type of products for that type of technology. So, like as I said, like the agencies, they don't themselves regulate, Congress has to provide them authorization, and these are all an examples of authorization Congress provided. So, for example, this is some of the original one, Food and Drug Cosmetic Act in 1906, whereas if you look at some of the recent ones, Food Safety Modernization Act, I think it's about now 5-6 years, and then you have Egg Product Inspection Act and so on and so forth. So, each time a particular category of product comes in, then the Congress passes the regulations and then get into that and so on. My understanding is currently they are going through another set of regulations, so that eventually those things needs to be considered. We talked about FDA and USDA in the same processing plant, but it is also possible you may have more than FDA, USDA, but you also have a local health authority maybe in your processing plant as well. So, suppose you are doing some poultry processing, you may do some hen breeding, producing eggs, you may have USDA involved in that operation, then you are doing cleaning eggs in the processing plant. If you do it in shell, it is FDA, whereas you break open and process it, then it is USDA FSIS. Again, because the way the regulations written, if you do it in the egg, then it has to be done by FDA. You just break open and then you have the liquid egg, it may be FSIS. Then it is transported to the wholesale and then handling institutional and so on, you may have a local agriculture health departments may involve. So, you can see that the need for specialized compliance person in each processing plant overseeing different regulations. So, they may be their full time job is to look at what regulations being developed or coming up, and then try to prepare the local plant to ready for some of those things, so that the product can continue to flow without getting stuck because they are not ready for the regulations. One of the useful thing food processor find useful is called food manufacturing practices, GMP, and GMP basically define the food is the following: a food shall be deemed to be adulterated, it has been prepared, packed, held under insanitary conditions, whereby it may have become contaminated with filth and it may be injurious to health. So, essentially what they are saying is, whenever you prepare food, you may have any bacteria or any other chemical contaminant, then they consider that as adulterated, and adulteration means you intentionally did this or you did this negligent, so that you got to allow that to happen. So, that means the processor is responsible for that, and then they can put you in contempt for the particular regulations. But the good manufacturing practices kind of provide a lot of common sense idea. So, they kind of try to say, give me minimum sanitary conditions. So, we talked about cleaning and sanitation earlier. So, they have some prescriptive cleaning and sanitation procedures part of the regulations, so that you can produce safe and wholesome food. And you have to, they do not expect you to do ultra clean, For example, if you are doing pharmaceutical type products, they expect even much more extreme sanitary requirement, whereas in the food processing sometimes those requirements are relatively modest. And a lot of times the FDA is kind of provides a oversight for GMP. So, in this picture it's probably not maybe clear, but you can probably see it may be a cockroach in your processing plant. So, if a federal inspector or FDA inspector walk in the plant and they see cockroaches or like flies and other things, that's a no, because they can probably cross contaminate a number of things and so on. So, here again what appears to be some type of corner in a processing plant where the surfaces became wet and it had some organic contacts and so on. You maybe have a mold growth or some biofilm, other things may be growing. Again, this is not acceptable. So, when you do some of this cleaning and sanitation, you have to make sure get rid of these obvious visible things from your system. And when you look at the facility, you have to store the equipment and materials properly. Again, these are all more common sense, but a lot of times people probably ignore those common sense because they don't have time or they are too busy doing other things. Then this is kind of left not done. You have to remove the waste or trash because you have to routinely do that, and then you have to properly maintain the road. You have to have a proper drainage, and you have to have a proper lighting, and you have to train the employees. So, for example, the employees going to the restroom, they have to properly wash their hands and they have proper dress code, all those things. And then you also need to have protection against pests, and in some areas processing plants may be open and birds can fly in and then they excrete things, and that can be unintentionally contaminate things. I think some of you may have heard about this. In California, they were processing a lot of leafy greens, and these leafy greens are coming from big multi acres of farm. Farm means you don't have any control over what's flying on the sky, and then they also have it's like more animals may be coming through. So, there were some birds flying over, and there were some pigs running over the farm. So, they excrete things. So, that means those kind of crossed with your leaves, they come to the processing plant. The processing plant, they did not do proper cleaning, and then they still attached to that leafy green. They were chopped. So, that means now they spread more places, and then it resulted in major outbreaks. And then they were spending a lot of time and effort to identify what caused the problem, how do you fix it, and so on and so forth. So, the point is, you cannot avoid animals going to the farm, or you cannot have plants fly into your field and so on. But if you do a proper cleaning and sanitation, you could have avoided some of those contaminants spreading further and then have all those outbreaks and so on and so forth. And I think for a while, I think consumers kind of worried because they were not sure consuming the produce is safe or not safe. So, the sale of the produce kind of declined for a particular time, then they kind of take a time to restore. So, it is important you do the cleaning and sanitation and taking care of your facilities. The equipment must be designed so that the food contact surfaces are smooth and readily accessible for cleaning and sanitation. Non-contact surface must be cleaned so that extraneous matter, microbe cannot build up and contaminate there. So, we kind of talked about CIP, COP, all those things. And one other thing, probably you heard the term HACCP, hazard analysis of critical control points. So, this is something important. So, you have to kind of try to look at your hazard, and then you kind of need to find a way to prevent them, and then you need to find a way to monitor, and if you have them, you have to corrective steps to fix it, and you verify your steps are working, and then you also do record keeping and so on. So, HACCP is something important to have. So, and federal agencies have their own share of HACCP. So, for example, you have a juice HACCP, this seafood HACCP, and then you have low acid canned foods, which is by which we are processing a lot of the shelf stable products, and then the acidified foods kind of processed by itself based on some of these regulations. So, if you go to the processing plant, they may be doing certain things certain way. Part of the thing is these are all prescribed by these regulations, and then they need to make sure it's kind of satisfy those requirements. So, for example, when you have acidified product, so remember acidified product is where you take a low acid product and then you add acidified, maybe for example, you may add some lemon juice or other things, so that you reduce the pH. So, that means under the conditions, the manufacturer should employ appropriate quality control procedure, so that the finished food do not present any health hazard. So, that means it is still acidified, there is no part of that is a low acid. When you have a low acid, that means it may allow the bacterial spore to survive at that cause outbreak. And they have to also make sure that the finished for pH is less than 4.6. Remember 4.6 is the classical value, where less than 4.6 Clostridium botulinum will not grow, above 4.6 it is a risk. So, you have to kind of consider that, and then you have to do frequent testing, so that you can able to maintain the pH is properly maintained. The next we are going to talk about is food additive. So, lot of times what is food additive? So, you have food and you may kind of add or directly or indirectly, and then it kind of added to a food, it becomes part of that, it is kind of called the food additive. So, you may have, for example, have certain additives or preservatives added to your food. In the same way, Congress defined radiation as an additive, because potentially when you do radiation, there may be radiolytic compounds formed. As a result, it can potentially consider as a additive. So, that kind of comes in from the food additive definition. So, where else can food additives can happen? When you have package has a lot of chemicals, and then when you have food, the food and package interact. It is possible some of the chemicals in the package can migrate into your food, and I think again that is not probably acceptable. So, you need to make sure that no migration of the material into food is taking place. When you are processing new technology, preparing new technologies. So, for example, we talked about PEF or ohmic heating. The electrodes may be pitting or it can migrate into the metal into the food, even though it may be small quantity, but above certain threshold is not acceptable. So, migration of electrode material into PEF is probably something needs to consider. Same way when you look at X-rays, UV, pulse light, these are all some of the sources of radiation sources. So, you have to pay proper attention, so that are you going to create any radiolytic compound under certain operating conditions. The next one is food labeling. So, what that means is basically Congress want the consumers to get what they food processors telling they are buying. So, in other words, they do not want you to misbrand anything. So, that means the ingredient and nutrition. So, that is why there is a ingredient statement, nutrition statement. So, that means if you are going to consume that product, you are going to have certain nutritional value or you have certain ingredients. So, for example, you may be a vegetarian, but if you have animal based product ingredient part of that, by reading the ingredient statement you may be able to identify that. Or you may be allergic to certain allergens like milk or egg or shellfish, tree nuts, things like that. So, you probably seen a lot of the statements. It says this product is processed in a facility that also process say peanut. So, that kind of provides. So, if you are allergic to peanut, you want to stay away from that product. So, I think that is basically one of the things. The standard of identity, basically what this is. So, for example, if you are going to have a particular variety of paneer, the consumers traditionally expect the paneer to be certain composition, all those things, but you do not want to create an artificial paneer or paneer made with a imitation material. So, that is where the standard of identity says, okay, if you say this is the cheese, you have these are the type of ways in which the cheese is made and so on. More recently, the question of all natural and fresh becoming more important, and with the advance of some of the minimally processed technologies, the food processors want to use the term fresh or fresh like product. So, for example, in comparison to canning, some of the newer technologies have more fresh like appearance, ingredients and so on, but FDA has not allowed use of some of those terms. The question is, what do you think is fresh? Fresh means different things to different people, right. So, what is fresh means and what is process means. So, for example, the raisins, right. So, where is this coming from? It is a dried grapes. Is there a fresh grape, a fresh raisin there? Can you call that as a fresh raisin, or how do you define that? So, like I think this is where the FDA has not kind of made a ruling on fresh, but I think this is a debate because people trying to use specialized terms. People say pressurized. So, like for example, high pressure processing, they kind of imply this is a fresh. So, they use the term pressurized. So, again some of them are marketing terms, but I think the FDA want to kind of try to more objectively use this particular thing. And pasteurization. So, in the past the term pasteurization until probably 1998 or 2003, the term pasteurization refers to time and temperature. Whereas, I think around 2006 FDA updated the definition for pasteurization. Now, the pasteurization can be accomplished by heat, time and temperature, or it can be accomplished by pressure and certain time, or UV and certain time, and so on and so forth. So, they kind of keep updating the definition with the times. So, we kind of talk about adulteration. So, you kind of want to avoid pesticide, chemical residue which causes insafety, and then you kind of also try to avoid like any decomposed substances, filthy substances, and if you process in sanitary conditions, and if you intentionally process a product with a diseased animal, and so anytime it kind of creates not good for people, you have to make sure that FDA can come after you because you are adulterating your food. So, even though you may not know, but I think these are considered as adulteration in the food processing. So, the term fresh is in the label when it implies that food is unprocessed, that means it's a raw state and has not been frozen, subject to any form of thermal processing, any other form of preservation. But if you look at it, most of the products in the supermarket today gone through some type of processing. So, if you look at simple apple, is it apple processed? You buy in the store? Yes, because when they get the apple, they probably wash everything clean, and then they probably add a layer of wax so that they can kind of able to extend the shelf life in all those things. So, from a stricter standpoint, that is a processed apple, but even though consumer think it's a raw product. The raw apple, basically you go yourself to the tree and pick your apple and so on. And the same way with the raisin, is it you go through drying step for the grapes, then you have raisin, but you go to the supermarket, you buy a fresh packet of raisin, you think it's fresh, whereas you keep it for 5 months, you may say okay, it's old, but in reality that grape has gone through a lot of steps before it come as a raisin. So, you have to kind of understand some of those things. So, FDA probably kind of exempt some products where they can use the term fresh. So, for example, they use waxes and other coatings. So, that is probably okay. And then if you have certain pesticides used or you can have some mild chlorine wash on produce. So, like we mentioned, when you prepare produce, you can probably sanitize with the chlorine or some type of wash step. So, they kind of still allow that type of thing happen. Now, I think if from a regulation point of view, you can still process raw foods and then the dose is less than 1 kilogram, but in practice I think nobody use irradiation because of their consumer concerns. The next one is the term GRAS. GRAS is called generally recognized as safe. So, what that means is you are using some substance historically over so many years, thousands of years, hundreds of years before the modern food processing, then FDA consider them as GRAS. But it is also interesting that what is considered GRAS in one country may not be considered as a GRAS in a different country. So, for example, in India people may be using lot of spices and other ingredients over thousands of years. So, it is kind of very standard. Whereas, if you are newly introducing them in the US, they may not recognize that as a GRAS because for them it is a new ingredient. So, they have to go through some type of test to verify whether it is safe or not, and so on and so forth. So, this is where I think you have to petition the FDA to get a GRAS status, and then for that you have to do number of tests to get them approved. So, we kind of talked standard of identity, we talked about, like for example, Swiss cheese, it has certain expectation from consumers. So, you have to deliver that, so that it kind of provides the consistent expectation from consumers. Now, when you look at the new processing methods, how do you develop a pasteurization process? So, I think first you need to identify the microorganism of concern in the food. So, that means different locations that target microorganism may be different. So, for example, you may have a one strain of Listeria in India, whereas in Europe maybe a different strain, and then US a third strain. So, when you are processing food in India, you have to focus on the strain what is commonly found in the Indian side, rather than using the strain found in US or Europe. And then you have to look at how much log reduction you need, and then you look at the food matrix impact, and then evaluate the efficacy of the process. Then you have to define the critical limits, and then what type of equipment and operating parameters you want to process. And then you got to develop good manufacturing practices, and then you do your HACCP analysis and so on and so forth. So, in other words, like for example, if you want to take and prepare a PEF as a pasteurization method for pomegranate juice as an example, you have to take that various steps, look at what is present in the pomegranate juice, and then how much reduction, log reduction with the PEF, and then you have to see whether type of pomegranate juice in different seasons have any effect, and then you have to validate whether you achieve proper reduction, and then you look at the operating parameters, all those things, and then provide the documentation to FDA for approval. So, the validation can be three different things. One is the biological, simulant, and mathematical. So, biological is probably one of the most one FDA recommends. So, what that means is, for example, if you are processing a soup product and it is a neutral pH, you may have a Clostridium sporogenes or Clostridium botulinum as your target. Clostridium botulinum is the spore forming pathogen, sporogeny is the indicator organism. So, you have to kind of use them to deliver your thing, and then you say, okay, with the process it reduced the population by certain logs. The simulant. So, simulant is maybe some type of chemical which has a similar behavior or property like your pathogen or your surrogate. So, for example, in milk there are certain indicators, chemical indicators which behave similar to the pathogens. So, if you absent those chemical indicators, then it's free from pathogens as well. So, that is something people use, but that is much more challenging because you have to first demonstrate your chemical simulant has similar characteristics as your pathogen. Mathematical modeling, we talked about, showed examples for different mathematical models, but oftentimes mathematical model has to be validated by biological means before you can use it in the process settings. So, we kind of talked about some of these things again, and we can probably skip here. Next one important thing is the records. So, simple thing, for example, when you pasteurize milk or when you do canning, we talked about time and temperature. So, what they normally do is when you do the canning, there is something called chart recorder. So, the chart recorder, if you have a old canning equipment, it's going to have a circular recorder, and then there is a pen, it's going to just move around the chart recorder, and then it's going to record at any given time what is the temperature the product is being processed and so on. So, in other words, this give you a proof in that particular batch of your canned product, it received 121 Celsius and above processing temperature. So, it's kind of record that information. Then after that processing done, you are going to identify that batch, and then you are going to store that chart recorder in a safekeeping probably about 3 years. Why? Because canned products have a longer shelf life. Maybe after 2 years a consumer can come in and then they can say, I got sick because I was consuming your canned product and that made me sick, so give me $1 million. So, one of the ways the consumers can or the food processor protect themselves is that they can produce the chart recorder from that particular batch and prove to the court or the regulatory authorities that I delivered proper time and temperature. So, when the can left my processing plant, it properly processed. So, this may happen somewhere at the consumer side or somebody else. So, I am not necessarily going to be responsible for that. If you do not have that record, then the food processor may be fined, or they may be expected to pay the consumers and so on. So, that is a chart recorder. The modern process equipment have what they call electronic chart recorder. So, it is like a, you are kind of, instead of writing on the chart, now you are digitally storing information in the computer, but they have specialized requirement. So, that means when you are processing and storing that information, there should be a way to safeguard that data, because you do not want to delete the data when the data is not suitable for you. So, it has to be kept there and then needs to be produced to the regulatory authority when there is a need. So, you probably want to maintain for various raw materials, packaging materials, finished products, and all the process certifications, so that you are kind of provide the scheduled process. So, what is scheduled process? The scheduled process is basically what I talked about in the canning. So, you are kind of delivering certain time and temperature. My pH is certain characteristics, my water activity is certain characteristics, and then my ingredients are the following. So, you kind of say, okay, these are the things you define to the FDA or tell the FDA I am processing my cans with. Anything you change, any ingredient. So, for example, you are processing some soup and it has a lot of fat content. Now, you get an FDA issue no objection clearance for your soup. The consumer trend changes, now you create a low fat version of that soup. So, that means you have to reduce the fat and you modify the formulation. You cannot just simply produce that in the plant. You have to go back to the FDA and then present the modified formulation, get the FDA approval, then start processing it. So, that type of thing is needed, so that it protects the consumer, but at the same time it also protects the processor, something have it happen. And you normally recommend about 3 years, because I think that is the length of time the regulation asks you to keep them there. Process authority. So, in many places they have a process authority who kind of keep track of all these things and get them processed. And if you look at what is the definition for process authority, what is the qualification of process authority at the moment? There is no legal definition for process authority. I think the regulation says you have to have proper credentials, but does not say you have to have a bachelor degree or you have to have a PhD and so on. So, what that means is, as long as I am experienced and I have been in the field for say many years and you are willing to take that risk, then you call yourself as a process authority and then do those things. So, larger corporations tend to have process authority on the staff, whereas smaller companies, medium sized companies, maybe they kind of hire a process authority as a consultant to work for them and so on. So, more recently FDA kind of started using what they call PSMA, where basically which is Food Safety and Modernization Act, because the earlier food safety regulations were done at the time when only products were made in the US or many primarily in the US. With the globalization, lot of products are imported. So, it means that you may have ingredient coming from country 1, country 2, country 3 and then assembled in country 4 and then export to a different country. So, how do you ensure your product is in compliance? So, that is where the Food Safety Modernization Act kind of comes in. And then there is also a growing population, which probably you get more seniors. So, for example, while this may not in India, probably we have more than 40% or more or younger generation, whereas in the US it is more seniors. So, even people with the age of 60 living like 70, 80 and 90. So, it is kind of there. So, FISMA Act, so that they can make it. So, they kind of 11. So, they kind of want to ownership of food safety regulation to, and then the FDA kind of provides more guidance. You also try to put more emphasis on. So, like the US regulations are very common. Ideally, they started as a and which is the most recent FDA regulation. Everyone has a role in ensuring safe food. The regulations are catching up. Stale, it's once it's there, maybe food additive petition in the radiation, the regulations are catching up, and the global is also kind of giving challenge. So, they have to kind of keep on updating it. There is a more need for education and outreach effect. People pay attention to the regulation. So, obviously, some of the documents are from FDA and then some other sources. Subject, but and I know no way I want to pretend as an expert in regulations. Be happy to discuss any question.
Hello, sir. As we know that authorities are there for creating responsibility or take on the side. So authorities should not be held for awareness around the such that we were discussing about technology are there on which doesn't have faith in. They are just the observation that it is processed, which I was or we were talking about. They see try to avoid those things. So authorities are responsible or to be held responsible to which extent that they should create an awareness, because creating a check is good thing, but creating an awareness about that check is also a good thing. That if we are just bringing it into your consciousness, it is not a hidden anything behind it.
Right. So, again, the purpose of the regulation is different from education, right. So, the purpose of the regulations are consumer protection. So, there are steps the processor need to do so that they are protected. So, I think that is one side. When you are talking about the ultra processed food, it is probably lack of understanding or mistrust from consumers about processed food, and that is a dialogue between food processors and maybe the consumers or even the academic participants and so on. And there is no need for regulations, because it is just a more education. So, for example, there are people trying to include ultra processed food, but there is no clear understanding on what basis they are causing and so on. They confuse the additives with processing, and then they summarily dismissing everything as harmful, but maybe there are ways you can improve upon some of those challenges. There are two different issues.
Yes, it's just look like similar that in agriculture sector, when we were going through the green revolution, that they mistook the opportunity of high yielding variety seeds. That's the same.
Right. So, yeah, I think anytime you kind of brings in innovation, you are always going to have a group of people have a confusion, and then it takes time to bring them on board as well. So,